Alright, today we are going to be covering section 2.7, graphs of rational functions, and I really could call this chapter review, or chapter 2, because what you are going to see here is all the stuff that we've covered in chapter 2, one way or another, kind of comes back, and then putting it all together into one graph is kind of the tricky part to this section. So we've already talked about rational functions, and the idea of rational functions, it's really a numerator over a denominator. So we call the top for this first slide, I think of the top as n of x, the bottom d of x, thinking numerator and denominator. What that means is you're most of the time going to have an x in the numerator and an x in the denominator. So here's some guidelines to help you graph, and we'll be following these on the next few slides. So always look to simplify. If you can get something to cancel out, do it. All right, that's going to be the first thing. A lot of times that's factor. A lot of times that's simplify if possible. You can think of that as factor and simplify if possible. All right, find the y-intercept. All right, you find the y-intercept by doing f of 0. Replace x with 0 and solve. All right. Again, sometimes you'll be able to find the y-intercept, sometimes you won't. Not every graph has a y-intercept. Or it might be undefined there. Find the zeros. All right. To find the zeros, that's the same thing as finding the x-intercepts. All right. So again, steps 3 and to find the zeros, you're going to want to set the numerator equal to 0 and solve for x. All right, step 4 is going to be find the zeros of the denominators. Why would I ask you to do that? Because from previous sections, we know that the zeros of the denominators are your vertical asymptotes. Those are going to be your dotted lines. Those will help you sketch our graph. You're going to calculate the horizontal asymptote. We've gone through that in previous sections. So that's by looking at depending about what the degree of the numerator and the degree of the denominator, we will be able to calculate the horizontal asymptote. And then here, 6 is going to be plotting a couple points. I like to do 1 point between every x-intercept and vertical asymptote. That helps me know where the graph is above the x-axis and below the x-axis. And and last but not least, draw a smooth curve connecting the points, being careful of your asymptotes. All right, so things that I would remember when you draw your graph: never cross vertical asymptotes. That's one thing. Never cross your vertical asymptotes. That's one. Always draw your line left to right. All right, those two can help you. Always draw left to right. That's going to give you a little bit of it'll give you that smooth, continuous curve you're looking for. Okay, so let's practice a little bit. Start with an easy one. Sketch the graph by hand. So we've looked to simplify, but we can't. So the important pieces of information would be things like a y-intercept. Your y-intercept here, you could try subduing g of 0, but g of 0 is undefined. So there is no y-intercept. Even though we tried to find one, it wasn't possible. We could look for x-intercepts. X-intercepts are found by setting the numerator equal to 0. So 2x minus 1 equals 0. Solve that, we would get that x equals 1/2. That is an x-intercept. We can plot that on our graph right here. Right, we get that point. We know x equals 1/2 is part of the graph. That x-intercept. We can look for vertical asymptotes. I'm going to call vertical asymptotes vertical asymptotes. To find our vertical asymptotes, we set the denominator equal to 0. We try to find the zeros of the denominator here. There's not a lot of work. It's x equals 0. All right, so I want to graph that vertical asymptote. Perfect. draw it as a dotted line. Next up, we have a horizontal asymptote. Horizontal asymptotes are found by looking at the degrees of the top and the bottom. When you have the same degree for both, you simply take the leading coefficients. So here, the leading coefficients, 2 and 1, your horizontal asymptote will be y equals 2. Okay, now, I've plotted all my x-intercepts, I've plotted all my y-intercepts. From here, it's just plot enough points so that I can draw a continuous curve. For example, what I try to do is every time I start at the left and I find a point from negative infinity to my first either asymptote or x-intercept. So I might say x equals, let's do g of negative 1. G of negative 1 might be a point, although you could do g of negative 2, negative 3, g of negative 10, all reasonable. So that would be 2 times negative 1 minus 1 all over negative 1. Looks like positive 3 to me. So that point right here, what this is saying is, because I have an asymptote to the left, this line has to follow my asymptote, my horizontal asymptote. As this line travels to the right, I have to follow the vertical asymptote. So that's how I can use that. Even though I just had one point, because I have asymptotes in both directions, I can now sketch a pretty decent curve. Between my vertical asymptote, the dotted line, right here, and this x-intercept, I would also want to plot another point because I'd like to know if it's above or below the x-axis. So I could try something like g of 1/4. 2 times 1/4 minus 1, all divided by 1/4. Can be a little tricky. I believe the top is going to be negative 1/2. Negative 1/2. The bottom is still 1/4. Looks like you're going to multiply that, so looks like negative 2 to me. What that means is 1/4 negative 2 is part of our graph. Now that leads me to believe, all right, well then it has to follow the vertical asymptote downward, and it's got to eventually pass through this point. So last but not least, I know this graph has to follow the horizontal asymptote out to the right. If I wasn't sure about this, I could test a point. For example, you could do something like g of 2. And if you do 2 times 2 minus 1, all divided by 2, you get 3 over 2, 1.5. And you can see, well, my graph, not perfect. I had it passing through 1. You could do a slightly better sketch if you wanted to, something like that. But again, the graph still follows the horizontal asymptote out to the right. All right, so big things. Notice I never crossed this vertical asymptote. All right, and in this graph, I actually never crossed the horizontal asymptote. There are some cases where you may cross a horizontal asymptote. We will see those as class goes on. All right. So let's keep it going. Try to sketch this graph using the same pieces of information. So thinking y-intercept. All right, y-intercept is calculating g of 0. G of 0, well that's 0 over 0 squared minus 0 minus 2, total 0. Well, this y-intercept is definitively 0, 0. I can find an x-intercept in a similar way. To find the x-intercept, I set the numerator equal to 0. Well, that same coordinate, 0, 0, the one I already plotted right here, 0, 0, is our x-intercept as well. Right now, we know we don't have any other x-intercepts or y-intercepts, which is good. Let's keep it going. Let's try to find our vertical asymptotes. To do this, we look at the denominator. I set x squared minus x minus 2 equal to 0. And here, I hope you're seeing a trinomial. We're going to factor that. X minus 2 and x plus 1. So because that's factored, I know my zeros are x equals 2 and x equals negative 1. That tells me I have two vertical asymptotes. Plot those on the graph right here. Okay, keep it rolling along. And the last one is going to be our horizontal asymptotes. Now, judging from the degree of the top is 1, the degree of the bottom is 2. Anytime the degree on the bottom is larger than the top, it is the same horizontal asymptote every time, no work necessary. I will plot that in as well. From here, it's just plotting a few points and making sure we correctly graph. So I might want to test a few points. Let's say I should test left of my vertical asymptote. So maybe g of -2 or g of -3. -2 over the opposite of 2 squared plus 2 minus 2. Well, those cancel. So that looks like -1/2 to me, or -2 over 4. That still tells me that coordinate is enough. Again, that's enough information to say the graph needs to follow the asymptote, pass through this point, and then it reaches another vertical asymptote that I can't cross. So your asymptotes are telling you behavior of the lines as you approach them. So as long as you're following the directions of the asymptotes, you're in good shape. Let's keep going. Now, this is a tricky one right here. We would need to do, it looks like that might be g of -1/2. Again, if you're ever in trouble, you could always use a calculator. So -1/2 over -1/2 squared. I'm going to put that up as +1/2 minus 2. All right, so actually take that. Let's see. So we got the top, -1/2. That's not changing. We got 1/4 plus 1/2 minus 2. So what do we have? We have -1/2. -1/2 divided by, that's going to be -5/4. Could multiply there, so it looks like we'd be getting +4/10. Looks like that's about 0.4 when you multiply. Flip the bottom fraction, multiply. It is going to be positive, so you could say that this point approximately right here is on the graph. Now that's good. I know we've got to follow our vertical asymptote. We've got to pass through that point I just plotted. We've got to pass through the x-intercept, but I should test. I don't know if this graph is going to turn around and go up or if it's going to go down. So I'm not going to graph anything yet. In fact, I'm going to test one more point. The next point I'm going to test is g of 1. I'm running out of space here, so let's try g of 1. That's 1 over 1 squared minus 1 minus 2. So that's going to be 1 over -2. Looks like -1/2. So we can plot 1 comma -1/2. That's right here. Now this tells me I can follow. I pass through the origin here, and then I know I'm going to follow the behavior of your asymptotes. And then the last point I need to plot is something like g of 3 or g of 4. G of 3. You could test g of 4 and be just fine. That's 3 over 3 squared minus, what's our formula? -3 minus 2. So I've got 3 over 9 minus 5, 3/4. That's definitely positive. Looks like right here. And it gives me enough to do all my end behavior. I got to follow the vertical asymptote. I have to pass through this point. As soon as it passes through this point, it's going to follow the horizontal asymptote. If you ever wanted to check your graph, you can go and you put the original equation into a graphing calculator. You should get a very similar picture.